Hi folks, this is Karim Raouf from IT Visualizer channel. They will continue our lab matrix labs, the video number 105. We have been discussing in the previous video the following, while still working with the case created or generated by Claude 3.5 Sonnet concerning how we can repair a corrupted Windows operating system using SFC and DISM, and we have seen that we have already created, or Claude has created, a lot of scripts or useful scripts to deal with the two situations when we have a simple operating system file corruption. We can use SFC, and if we have a complex corruption of the file systems, we can use the DISM, then reuse the SFC, and we have seen a lot of useful scripts to do so, and very complex and fantastic case. So what if the SFC and DISM doesn't work? Then we need to do other solutions, for example, to have an in-place upgrade or to have a Windows reset. So we have stopped the last time at the situation where we are we are in a need to have an in-place upgrade. So let's see the generated uh, diagram concerning this case generated by Claude. So we have system issues persist, we have assess impact, moderate issues we can have an in-place upgrade, benefits keep applications and setting, less disruptive, drawbacks takes longer time, may not fix all issues. This is if we have moderate issues. If we have severe issues, we can reset Windows. Benefits fresh start, fixes most issues. Drawbacks loss of application, more setup time. So these are the two cases. We will see how we can do both. Even though it seems to be simple, we just put USB flash and then boot and then begin the in-place upgrade, but Claude uh, make it uh, more rich, not to only do that, but if you need to make it for a bulk of PCs, he have already generated a script to do that, and the same for the reset. But let's see what is the answer of Claude concerning the two cases. The first case is the in-place upgrade. We can see here that the first method is to mount ISO image. This is the path of the ISO image, and we can go to the setup.exe program, and then we can see the parameters. We have auto upgrade, quiet, no reboot, show OB none. So these are all parameters for we can see these are for quiet upgrade. So he will try to upgrade without uh, reboot. This is a new thing, so I think I need to have also a simple question. If we ask perplexity like this one, perplexity AI, and then ask it this question, and then get this part of the script uh, like that. So we'll copy that and then uh, analyze this script, and will it really upgrade Windows without reboot? So let's see how this will be done. Let me first take the pro search and see this. So let's see the answer. Here is talking about PowerShell script designed to initiate a silent, quiet upgrade of the Windows using a mounted ISO upgrade method. The script uses a mounted ISO image as dictated by the setup path. Okay. Setup script auto upgrade automatically start the upgrade process. Quiet runs the installation without requiring user interaction. No reboot prevents system from automatically reboot after the upgrade. Show obviously this is out of box experience. None surpasses the out of the box experience. We all know the questions uh, that will be asked by the Windows in the initial setup. Your secret questions, your language preferences, your time zone, a lot of things. Reboot. So we have no reboot includes which intended to prevent an immediate reboot after the upgrade. However, some upgrades may require a reboot to complete the installation process fully. So here it didn't give us uh, any references to his answer. So I think this is generated by the AI tool. So let's try to get this one and ask a couple of questions first. Let's ask Copilot. We see if also this will work or not, or this will be analyzed in the same way. So he's just analyzing the script. And will it upgrade without a reboot? The no reboot is intended to prevent an immediate reboot or prevent after the upgrade. However, some upgrades may require a boot to complete the installation. The script successes the reboot, but it may always be successful depending on the specifics of the upgrade being performed. The script is designed to upgrade Windows without immediate reboot, but the actual behavior depends on the requirement of the specific upgrade uh, being uh, okay. Feel free to ask. I need to do something. I need the commands to run upgrade for Windows 11 and the switches. Let's see if he will get us a more valid answer. I have 16 sources here. Let's see how this will go. So we have the setup commandlet. Okay. So here, for example, is giving us a PowerShell commandlet. This is setup auto upgrade compact, ignore warning, quiet, no reboot, dynamic update disable, EULA accept, auto upgrade automatically starts the upgrade process. Okay, this is the reference. Quiet runs the installation without user interaction. No reboot prevents the system from automatically uh, rebooting. Dynamic update skips downloading the latest update. Okay, this also can be a good addition to the script. Accept EOLA. This is accepts the end user license agreement. Compact ignore warning ignores compatibility warning. So here he has another thing. If we go here, we have show OB none. So we need to get all of these parameters to make sure that we have already the correct thing. So if you go there, and here is the setup commandlet options. So I think here this is a good thing. Now we can see that we have no reboot, show OB none or full. So I think this is very good. Also we can see here that these are all the parameters that we need to make an upgrade. Okay, and we can do it from the command prompt. We see all of the setup slash switches we need. Okay, and so this is a good thing. There is the pre-upgrade validation compatibility check with setup. So here he giving us the commandlet setup auto upgrade no reboot. So all of this will be done in one line. And then I think now uh, this is the variable if you have compatibility, and then you will get a certain number. It tells that Windows does not, it's not compatible, but I think we can bypass the compatibility check, and then uh, we can continue update. Okay, so we can see here that uh, I think this is a good way, but actually, so here is talking about you get the error, then try to upgrade Windows build. You cannot keep the personal file because your current Windows will try to upgrade. You cannot keep Windows setting personal and apps because your current version of Windows might be installed on unsupported directory. The source of the problem is that the upgrade wizard could not find default Windows 10 app folders. To fix that, we go to the registry key, find program files diary. It must contain full path to directory where the system program files folder is kept. If your system is installed on C, the value of the parameter must be C program files. If the system is installed on another drive, the path will be different. For example, E program files, edit the value uh, so it contains the full path to the program's file directory in your Windows installation, so on. So in same way, the same values of the parameter of the program files directory x so and so file path. Anyway, so we can see here is a little bit of uh, this is the script, so this seems to be correct, and let me ask it. So okay, this is the way that we can, this line will do us a setup, okay, to or upgrade to the Windows in one line. Okay, this is the line without a reboot, and very simple in one line to do that dynamic update. So we can add to the script here also dynamic updates, okay, slash dynamic updates to make it uh, more thing. Now we can see method 2 using, this is the first method using one line parameters for quiet upgrade. Method 2 using media creation tool, so you can go to Microsoft and download the media creation tool, which will after opening it, it will go and download the Windows ISO image and put it on a flash. Okay, so I think we can use the first method, which will be much easier. uh, as for reset Windows, we have this command, let system reset keep files, system reset factory setting. Is this also the right commandlet? This also can be one thing we need to say system reset. Let's see if this is the same commandlet. I need just to make sure that this is the same or it is correct. What does this command do exactly? So we can go like that and get, let's see. So okay, this seems to be the reset uh, option. We can tell him to reset factory setting or to tell him keep files. So we have here also how to reset Windows. Let's go and do like that. We have the reset option when IRO. So this is how we can do a reset. If we can do it from the command prompt, let's see how we can do that. This is the GUID method, how to do it through the graphical interface. We need to do this from the command prompt, so this will be easier to do that for a bulk computers, to do this in a script and do this for a bulk of computers at once. So let's see how we can do it from the command prompt. So we can go further. Here you go. This is all of the process of the reset. Now we can open the terminal, and then we can see here we have factory reset, remove everything, keep your files. So I think one thing I need to make sure that the other keep files, he's saying keep files. I have already tell him the keep reset keep files. So this is, he is telling us that how does system reset keep files differ from Windows reset factory. So I think there is this commandlet. You will make a summarization. So yes, this seems to be specifically installed, but keep your personal files. So here we can see how to remove. So I think he is correct. Now we can do a reset and an upgrade from the command prompt. So if we go there and see the key differences in place upgrade, keeps all apps and setting, takes longer 1 to 2 hours, less disruptive, good for fixable corruptions, reset windows, fresh start, faster 30 to 60 minutes, remove all apps, best for severe corruption. Which options interest you more? Junior IT admin, the in-place upgrade sounds less disruptive since it keeps apps and setting, but I have a question. How do we know when to give up on DISM repair and move to one of these options? Is there a specific error message or condition we look for? Good question. Here is our decision criteria. Function to assess system state and recommend next step. So here is something to run. We will run the DISM health check, and then we will go and see the system log ID 6005 and 6006. Okay, and what is this registry key? Reboot. So here is seeking to see if there is any problem with the system files, and if a repair process is done and with the DISM and it reads a reboot before doing anything. Decision matrix. So here is multiple boot attempts detected. Consider reset Windows, uh, component store, try in place upgrades. So here he is uh, trying to see how much restarts are done uh, maybe by the DISM, and through that if we have more than 10 reboots, I think this will be considered multiple boot attempts detected. Consider reset Windows. uh, More than 10, greater than 10. So less than 10, then component store corruption, try in place upgrade. So I don't know if this is a good way, but let me first ask ChatGPT to explain this script, and uh, let me ask it also one thing here. Is the decision matrix to have in place upgrade or Windows reset based on number of reboots of system greater or less than 10 reboots. Correct. Let's see if he will be able to give us also a decision concerning our question. So we can go like that, Control C, and try to ask him a simple question. Okay, let's see what will be the answer here. So here he is analyzing the script. Let's see. Here we have test system repairability is designed to assess certain aspects of Windows system health and then recommend one of the two recovery options, an in-place upgrade or a reset Windows. Data collection function builds on assessment by collecting data from several system checks by the DISM, SFC, and boot success count. It retrieves events ID 6005 and 606 from system event log over the past day. These events typically relate to a system startup and shutdown. Okay, so these are two system shutdown and startup. It counts these events. The number is interpreted as an indication of how many times the system has successfully booted or restarted in the past day. Pending reboot checks whether there is a pending reboot by testing the existence of a specific registry key. How does the decision matrix work? The script first examines the output from the component store check. It uses a regular expression match corruption detectance. You will see the DISM see the DISM output and the SFC if determined whether an indication of a corruption. Branching based on boot count. If corruption is detected, if he sees this error in DISM, and then we have more than 10 boot events, the script assumes that a high number of successful boots over 10 within the last day indicates repeated rebooting. In this case, it recommends a Windows reset by displaying multiple boot attempts detected. Consider reset Windows and returns the string reset. So 10 or fewer. It suggests while the component store shows corruption, the system hasn't been rebooted excessively, though it recommended the in-place upgrade. Okay, so he also take the decision based on boot things. Okay, although the assessment also gathers information from SFC and pending reboot checks, the decision matrix in the provided script only uses the output of the component store check, not the DISM, and the boot event count to decide between upgrade and reset. Is the decision matrix correct regarding the number of reboots? Summary of the logic. Yes, the script uses the number of boot events as a proxy for the number of reboots. More than 10, okay, this is reset, 10 the fewer. So the threshold of 10 boots is an arbitrary cutoff chosen by the script or author. The script assumes the high number of boot events greater than 10 reflects instability that might be better addressed by Windows Reset rather than an in-place upgrade. Final answer. The script assesses system repairability by running a series of DISM for component health, SFC, counting boot events, and checking for pending boots. Its decision matrix specifically looks for the phrase corrupted detected and the number of boots. So yes, the decision matrix is indeed based on whether the boot event is greater than so and so. So, okay, so he's saying that this thing is correct. Let me again ask, for example, Gemini to see if this also can be a good answer. So now we can go and run. This is the latest one, Gemini Pro Experimental, and we'll go do experimental thinking. Let me do first with the normal one. So here he is giving me also an enhanced version of the script, even though I didn't ask him to do that. So this is unexpected good thing done by Gemini, even though I don't see, I'm not putting him in one of my favorite AI tools, but let's see, I need one thing. Is the decision correct? Is a reasonable heuristic rule of thumb, but it's not foolproof and have some important caveats. Correlations versus causality. A higher number of reboots correlates with a higher likelihood of severe system problems, does not prove that the reboots are caused by the component store corruption. but he will check for that before. He will see if there is corruption. If he have a corruption detected, okay, he will begin doing that. So we need to make sure if this corruption is there, then it will go that it does not prove. It will give us not prove that caused by component stored. It could be either underlying issues, hardware failure, and so on. So 24 hours is arbitrary. So you are checking for the last reboot for the 24 hours. A system might have been stable for weeks, then experiencing a series of reboots in the last few hours due to specific isolated event. User initiated reboots. The script doesn't distinguish between automatic reboots due to crashes or updates and user-initiated reboots. If the user manually rebooted the system multiple times for some other reason, installing software and so on, so this would falsely inflate the reboot count. Shutdown versus reboot. The script counts both shutdown and restarts. A user powering down their machine at night and starting it at the morning counts toward the total. Other factors, the script only considers component store corruption and reboot count. It doesn't take into account other potential indicators of systems such as SFC results, the severe of the component store. There is one store corruption. The script treats all detected corruption as the same. DISM can distinguish between repairable and non-repairable. So he's saying if corrupted is repairable, he didn't say that the corruption is there and it is repairable. So you need to make sure that it is repairable. If it is non-repairable, then we can go to the in-place upgrade or reset. So this was not stated in the script. The persistence uh, of pending reboot user reporters. So here he is giving us an improved script. So I think all of these things are correct. So even though he's seeing the DISM, uh, seeing the DISM here, let's go again to ChatGPT. ChatGPT is saying that uh, here he examines if there is corruption detected, but he need to get repairable. If it is, then we can go, or we can cancel the in-place upgrade. So here, one thing again before that, although another thing here said, and I already uh, have a note. Although the assessment gather information from SFC and pending reboot checks, the decision matrix provide the script uses only the output of a component store, so he didn't take the result of SFC and the boot count to decide between upgrade and reset. So he's taking the output of the DISM and the boot count. And we see that these two are misleading because he didn't he take the output which is corruption detected, but he didn't say if it is repairable or unrepairable. And we have also the boot count can be for uh, other uh, several other factors, maybe a hardware failure, a driver. So he didn't see that. So here is the improved version function to assess system state and recommended next steps. So here is the events. Looking for a couple of events include boot shutdown and critical event errors, and we will see the pending, also reboot pending, and then improve decision matrix, assess results, component store. So he adding the SFC, the component store, the boot events, pending reboot. So after that, match, no corruption detected. Assessment did not find any. This is for the SFC. Right, no significant corruption detected, no action required. Okay, and we have corruption detected by DISM, but we need to make sure if it is repairable, then we don't need an in-place upgrade. And pending reboot. Okay, more aggressive approach if many of your boots a pending reboot exists or corruption is not repairable. Okay, so if it is not repairable, then we can begin seeing the reboot count or the boot count. So we have boot success 5 greater than 5. Okay, so multiple boot issues, pending reboot or unrepairable corruption detected, consider reset windows more than 5. okay. Component store and file system corruption detected. SFC and DISM. Try to repair DISM. Restore health. This if we have it repairable. If it is non-repairable, so we need to here component store and file system corruption. Try to repair using DISM restore health. So it's checking the output if DISM have repairable things. You need to run this to restore it, and the SFC repair, and then we can see this is repairable. The unrepairable we need to do for example on a store potentially repairable, try in place up. No, this is component store corruption if it is irreparable, not repairable. Try in place upgrade. System crash to repair. Okay. Unknown system state. Manual is diagnosed. System state. So let's see here what this will do. Get the event viewer filter now. Events included event ID 12 startup, 13 shutdown, 41 unexpected shutdown, 1074 user initiated shutdown and restart, and 608 previous system state shutdown was unexpected. In addition to 605 and 606, this provides a more accurate picture of system stability, handles no corruption. Add a check at the beginning to see if both DISM and SFC report no problems. If so, it outputs no action required. Repairable corruption check. The script now checks if the DISM output contains the word repairable. This allows it to differentiate between situations where DISM can potentially fix the problem and those where it cannot. Uh, Lower reboot threshold. The reboot threshold is lower to 5. This makes the script more sensitive to potential problems. Pending reboot consideration. The pending reboot issue is now incorporated into the decision. If a reboot is pending, a reset is recommended. This often indicates a failed update or other incomplete operation. Combined condition. The logic now combines multiple factors, reboot count, pending reboot, repairability, to make a more informed decision. SFC result used. The script now uses the result of SFC scan. If SFC finds integrity violation but this finds no component store corruption, it recommends SFC. So this is a good thing actually. If both find issues, it recommends trying them and SFC repairs before escalating. Running repairs. The script now have option to run repairs, not only checking. Unknown state handling. An else block is added to handle cases where none of the defined conditions are met, suggesting manual diagnostic. Clearer output. The script now prints the result of each assessment step before making a recommendation. This helps the user understand why a particular action is suggested. Return value. The function now returns more specific values like no action, reset, upgrade, repair, unknown, to indicate the recommended course of action. This is better for pragmatic use. Comments. Add more comments to explain the logic. The improved version is still a heuristic, but significantly more robust and considers more factors, making it better diagnostic tool. It also more transparent in its reasoning. However, a definite diagnostic often requires more in-depth analysis by a skilled technician. So anyway, so it's giving us, I think this can be a good one. Okay, so let me get this script. Okay, so we have it, and we can go, and here is a better script generated by another AI tool. Uh, Explain, okay, or enhance it, and correct it if it is not correct. Okay, so now we have a more reliable script. Now we can see that and see the analyzation. So even though this is the latest OpenAI tool, but Gemini here, regional or thinking of Gemini is better. So let's see here. Boot event resolve confirm separate commands for logic decision. Note that the script still depends on matching output text from DISM and SFC, so you may need to adjust the match strings if your system output differs. Okay, so we can see all of these. Has he done any error handling, parameterization, separation of concerns, repair steps, uh, logging, clear, formatted, so on. So I think this seems to be a good one. So now we have, if we go there, now we have a script to, or an enhanced script uh, to add more decision making for if we have an in-place upgrade or a reset. Okay, so this is a good one. Move to, so here, move to fallback options when DISM fails 3 consecutive times. Error 0x800F0922 persists after offline repair. System becomes unstable, crashes or boot issues. Repair time exceeds 2 hours. So he didn't mention that in the script. He just only giving us 10 reboots. Okay, and if he sees component store corruption. Okay, so this is our, again, DISM fails 3 consecutive times. Error, this one, system becomes unstable. Repair time exceeds 2 hours. So okay, now he is modifying his script. Let us analyze our current repair status. So I think he will modify this script. Let's see the answer here. So he's trying to see the DISM log. Okay, so he's leaving this script without changing it, but he is checking. So this is the original script. He will not, he will say the boot, or he will try, he will do two things actually. He will see the number of boots. Okay, if it is greater than 10, then he will consider reset. If it is less than 10, then we need to have an in-place upgrade, and uh, before, or he is having an extra step to check the DISM logs to see. Okay, so now we need to check the DISM logs. Okay, so it is greater than 10, then the DISM, so the DISM will contain some problems. Okay, so we need to check the DISM logs before going to repair or in place upgrade or reset. So even though this seems to be separate, so we will use this script separately, but we have another step for analyzation. We need to go to the DISM log and we need to check for errors in the log. The last one, I think here is checking for errors in the DISM log, and then we have current repair analyzation. Duration, we have minutes. DISM attempts, last error. So here is checking these criteria. So he will check the DISM log. If he sees fails 3 consecutive times to repair by DISM, and he sees some errors and the repair time exceeds 2 hours, then this is a sign that we need to have an in-place upgrade or a reset. Okay, depend upon the time of boots that that was done. Okay, So if we go there and see here, we have these things, and then we have decision tree analysis. So here, recommended action: if repair status is greater than 120 minutes, consider moving to in-place upgrade. Duration exceed 120 minutes more than 2 hours. Else, if we have this error, consider moving to reset Windows. Uh, and if we have DISM attempts fail more than 3 times, consider moving to in-place upgrade. Continue repair. So we have two scripts, one that will check the boot time, okay, or the number of boots, okay, and the health check of the DISM. So he will check the health, or we have the health check and the number of boots. And we have seen there is a flaw in this script, which seems to be not that good. But I think the other script seems to be more valid. Here he is trying to see deep or analyze the DISM log more and see uh, some criteria like DISM failure, offline repair failure, repair times exceeds 2 hours. So this seems to be a more reasonable criteria to decide if we can go to in place or reset. So he is saying that if we have an in place upgrade, or we have sorry, if we have uh, uh, a repair exceed 2 hours, then we need to move to in place upgrade. If we have this error, then we need to consider reset. This error, this is the offline repair, and we have three attempts by the DISM and they fail. Then we need to have in place upgrade. So the only way, or the only thing we need to do, or to do a reset, if we have this error from the DISM. So this seems to be a good script than the other one. What do you see in the analysis result? Should we continue with the current repair or move to one of our fallback options? Junior admin, I see duration is around 45 minutes. We had 2 DISM attempts, still seeing error this one. So we have 2, we have 45. So we see this also. I think we will go to in-place upgrade because we have a repair process less than 2 hours. Since we are still seeing the corruption error, should we start preparing for in-place upgrade, or should we move it more time? Okay, so we see, since we are seeing persistent corruption but haven't exceed our time or attempt threshold, let's prepare for an in-place upgrade while giving the current repair a bit more time. Parallel preparation while monitoring current repair. So what we need to do here, we need to parallel preparation while monitoring repair current repair. So verify system readiness for upgrade. Okay, this is good. Check minimum requirements. Continue monitoring current repair for 15 more minutes. So we will initiate another repair and check the log files and see to make sure that this, or we are doing the best we can do. Check readiness results. So if we have the necessary hardware to make an upgrade, so this will be set system readiness for upgrade. Okay, so we have green or red. So if you, for example, are upgrading to Windows 11, he will see the hardware if it is I think, no, this is not for Windows 11. He is seeing some things like disk space, memory. So I think this is for Windows 10 because this seems to be less 4. No, I think this is the minimum for Windows 11. You need to have 4 gigabyte. We have 20 for the hard disk. Some things here are missing. For example, we need to have TPM, for example, and a lot of things. So this is still needs an improvement. So again, I think I can take this script and ask both. uh, Let me first ask ChatGPT to do something like that. Explain this script, and I need to have the same thing here. Let me have something like that where it is. Uh, uh, okay, 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 and is the decision matrix correct or not? Let's put the script here, and we can put like that. Sorry, put this the script itself, so we can go like that, and we can get the script like this one, copy, and go to ChatGPT and make it like that and do like that. And let's take the whole answer or all the question and do like that and see what will be the answer. So let's see. Decision matrix is logically consistent with its intended strategy, provided that chosen thresholds 120 minutes and 3 attempts. Attempts also actually reflect the conditions under which in-place upgrade or Windows set is preferred in your environment. So again, he is saying that this criteria is good. So let's see if Gemini will agree to that criteria, and let's think or let's see his answer. So now we can go and do like that. Again, he's getting another improved script. I didn't ask him to improve it, but this is a good thing done by Gemini. Let's see also what is his answer. Now he is talking about, is the decision matrix correct? Yes, the decision matrix is largely correct given that the information it's using. It is a significant improvement over a simple reboot count. So as I've told you guys that this is better than the first script. It's well structured and considers the relevant factors. However, there are always potential improvements and limitations. DISM counting. The method of counting DISM attempts by searching for DISM in the log is good but could be improved. It might capture lines that aren't actual DISM executions. Messages mentioning DISM. A more robust method might involve phrasing the logic for specific DISM start and stop events or using regular expressions. Last error limitations. Focusing solely on the last error in the last 100 lines might miss earlier critical errors that were overwritten. A more sophisticated approach might involve analyzing the entire log or a large portion for pattern of errors. Also, checking all of the lines that has error will give a more definite analysis. Okay, other error codes. The script only checks for one specific error. Okay, uh, there are other errors that could indicate specific problems such as just different solutions. Errors related to specific Windows component, driver issues, etc. Context is king. As always, the script is a tool and its recommendation should be considered in the context of the specific situation. A skilled technician might have additional information or insights that would lead to a different decision. Uh, no unknown state. The script always recommends some action. It might be beneficial to add a condition that handled cases where the situation is unclear, no errors found, but the system is still unstable. It does not check for SFC logs. Again, he is not checking for SFC. So now you have an improved script. Let's see here what he's talking about. Now we have uh, okay, checking the DISM logs, more precise DISM count, so on. So DISM logs and CBS logs. Okay, and checking for errors in the DISM and checking for errors in the CBS log that SFC logs or the activity is logged to the SFC logs to the CBS log. Now we have the repair duration DISM SFC, so he's adding the SFC again, number of DISM errors. Okay, so greater than 0, then we have, if errors count is greater than 0, then we have red. Okay, SFC, this is the first 5 lines. So let me see here, greater than 0, DISM errors first 5. So okay, let's see his explanation for this script. So you see SFC errors and then DISM and then improved decision tree 180 more than 2 180 means 60 no, I think more than 2 hours. This is, I think, 60 120, I think 3 hours. Increase duration threshold to 3 hours. And we have this error, persistent corruption. Add another error, another common error, this error and this error. Okay, and then moving to reset. So consider moving to reset Windows source files not found. I think this is not correct. Why? Because this means that DISM cannot get healthy files, maybe because there is no internet. Okay, so this is not a good choice to add it to our criteria. This is not correct because source files are not found. This can be solved by making the DISM try to get healthy files from the ISO image. Okay, so we can see here greater than 5. Okay, so let's see the explanation. More precise DISM attempt counting using a regular expression to match lines which so and so. All errors captured instead of just the last error. The script now retrieves all lines containing error. Okay. SFC and log analyzation. Multiple error checks. Add a check for error. This one, which often indicates that DISM cannot find the necessary files for repair. This is not correct, so we need to... Okay, this is not correct. It cannot find files, then maybe there is a WSOS in place, or there is no internet on this machine. Increase threshold. Slightly increase the duration attempts threshold to avoid escalation. Combined conditions 100 more than 120, so better output. Show number of DISM SFC errors. Print the first 5 DISM and SFC errors, if any, for quick inspection. This is much more helpful than just printing the last error. Okay, checking for multiple SFC attempts with errors. Checking of number of errors. A condition to suggest in place upgrade if multiple SFC attempts were made with errors reported. So maybe SFC have errors, but this can be solved by DISM. Okay, consider moving to in place upgrade if repair went more than 2 hours. Okay, I think this can be tweaked. Okay, so I think this is not there is some things here I cannot understand from Gemini. Okay, so this is not correct, and actually uh, we should not see the SFC errors, because SFC errors can be solved by DISM. We need to concentrate on DISM, okay, not SFC. Okay, so I think this is not a correct script, so I think this script is fair enough, but we need to okay, I need to add a couple of things here. So we need to tell him to maybe not see the last error. Okay, we can see the last 5 errors or something. So let me do something here. We need to tell him to no, there is some uh, uh, incorrect statements. First, SFC errors can be solved by DISM, so we should focus on DISM errors. And as for the DISM error, where is this error? This can be due to the situation where there is W source in the environment, or the PC is not getting to the internet. So we cannot go to Windows reset based on this error. Okay, let's see that. Let's see. Key change in reasoning. The logic now correctly prioritizes DISM errors over SFC errors. SFC failures are often a sequence of a component store corruption, which DISM is designed to address. Correct handling of this is the most crucial correction. The script no longer recommends a Windows reset solely based on this error. It now provides a specific helpful message. DISM error not found. Check WSOS internet connectivity. Attempt DISM with source if necessary. The recommended action change it to attempt DISM repair with spelled source. Okay, that's it. Ensure the machine has internet access to download repair files from the Windows update. Specify the source. Okay, that's correct. The script uses right host to inform that it is a source file not found error. SFC handling. The script will check for SFC errors and attempts. The key change is it now recommends attempting ADSM repair before escalating to an in-place upgrade or reset if multiple SFC attempts fail. This is correct sequence. Try to fix the component store before restoring to a more drastic measure. If the DISM repair option is already suggested before because of this, the SFC failure suggestion is skipped. Other improvements. carried over from the previous but still relevant, precise DISM attempt counting, capture all DISM errors, increase duration and attempt threshold, clear and more informative output. Explanation of the corrected code. So check duration for 3 hours. For crucial errors, check source. So he's re-explaining himself. Check for multiple errors. It's been run more than 5 times. Suggest attempts has more than this multiple repair attempts more than 5 times. Suggest an in-place upgrade. Check for high numbers of DISM errors, more than 10 errors. Suggest an in-place upgrade. SFC failure, multiple errors. We need to first make a DISM repair. Check for duration and DISM errors together. If the repair has been running for over 2 hours and DISM errors, suggest an in-place upgrade. Continue the current repair. So where is the reset? So now the reset, where is the reset recommendation? So here we have only in place upgrade. So now he didn't give us the in place upgrade. What about in place? What about Windows reset option? Let's see how he will get this. So let's see now. So let's continue. Just wait for a moment, guys. So let's continue, guys. Here we can see that he already missed the option of Windows reset. So he need to add it to the script. A Windows reset is a more drastic measure than in-place upgrade. Essentially reinstalls Windows. So when we need to do that, where a reset becomes a strong recommendation, resistance, unrepairable corruption. Okay, so this was stated before in the script. Okay, failed in-place upgrade. This is correct also. If you have failed in-place upgrade itself, a reset is the next logical step. Yes, that's it. So this underlying issues so and so. Repeated unexplained system instability. The system experienced frequent crashes, blue screen of death, other major stability problems even after DISM. The 3 had run and potentially even after in-place upgrade. A reset might be necessary to eliminate any deeply rooted software conflicts or corrupted file systems. Malware infection beyond simple removal. Okay, that's correct. Reset can be an option. User preference, clean start. Sometimes a user might simply prefer a clean installation of Windows. Okay, that sometimes is the last thing to do. So here is adding again the reset option. Let's see here what is the logic behind his script. Okay, in place upgrade attempts tracking. A new key, in place upgrade attempts, is added to the repair status hash table. This is initialized to 0. Crucially, this variable needs to be incremented outside of this script. Whenever an in-place upgrade is attempted, the script snippet cannot know on its own whether an in-place upgrade has been tried. It needs to be informed by the larger repair process. You need to tell him if you make an in-place upgrade before or not. This is a critical point. A real-world implementation would need a mechanism to track this. Okay, setting a registry key, writing to a file, or logging an event. Okay, let me try to see if give this to ChatGPT to enhance it. A placeholder function was in place upgrade attempt is added. The function is a stand-in for the actual logic that would check for a previous in place upgrade attempt. In this example, it simply checks the value from repair status. Okay, failed in place upgrade logic is added to decision tree. If was in place upgrade, return true. If in place upgrade tried and preparably, still running this script. Okay, okay, let's wait for a moment, guys. So let's continue, guys. Here we need to have a way to get if there is an in-place upgrade that has been done before, so the script can recommend to do a reset. So the most important practical consideration is how to reliably track whether an in-place upgrade has been attempted. The script snippet cannot do this, so we have seen this. The script provides a recommendation, but ultimately the decision to perform a reset or in-place upgrade should involve user interaction. A reset will remove installed application, so the user need to fully aware of the consequences. Okay, so order of operation, try SFC DISM. If those fail, in-place upgrade. If in-place upgrade fails, consider a reset. So let's see if we can take this script and copy it and then explain this script and correct it if it is not correct. So need to put like that and see what will be the decision, and let's see if we can do like this. The main correction was to ensure that the function was in place upgrade is properly called with parentheses so it return value that can be used. Let me see. So let me see first if there is anything here. So where it is, script explanation, repair, uh, repair status, DISM attempt or errors, SFC, errors in place upgrades, attempts. The script comments note that the actual tracking of in place upgrade attempts must be done externally. So this is good. A function to check for upgrade. Note the original script that the function was referenced without parentheses. In the PowerShell, you should must call it with parentheses. Okay. Okay, outputting so and so decision missing many errors. So let's see the final thing here. Below is the corrected version of the script. The primary corrections are ensuring that the was in place upgrade function is called correctly and use consistent property access. Example count. So here is the script. It collects data from DISM. This is the summary. What does the script does? It collects diagnostic data about repair duration, DISM, SFC attempts, and errors from log files, output a diagnostic summary, and then uses a series of of conditions a decision tree to recommend one of the several actions. Move to in-place upgrade if the process is running too long or there have been too many attempts or errors. Suggest a window reset if a persistent error like this error is detected or if an in-place upgrade was already tried. Recommended specific troubleshooting steps if a particular DISM error like this is encountered, otherwise continue the current repair process. The main correction was to ensure that was in place upgrades properly called to assist to return value that can be used. We ensure that the collection properties so the corrected. So let me ask something. How can the script verify if an in place upgrade was done even it says that no registry value can get that. The studio must rely on so and so. Several approach might consider check logs, look up for upgrade. Mhm. Script check for resistant loss folders. Since there are no registry flag for in-place upgrade, a common issue is to create your own marker. For example, your script initializes an in-place upgrade, have it write a flag to do a custom. Okay, so here we need to have a way to tell him that this was in place upgrade attempt. Okay, modify the script to based on your recommendations. Okay, let's see if this will go. So decision tree remains similar, but now one of the branches used was in place upgrade attempt. The custom marker to decide if Windows reset should be recommended because the in place upgrade was already attempt and assumed to have failed. So now checks for marker files like upgrade marker. If the file exists, that is it. Returns true, otherwise it returns false. Tip: when your upgrade process begins, run set in place upgrade marker or incorporate the logic to create the marker. Uh, okay, okay, let me see here. So notify script to use a custom marker to help verify whether an in-place upgrade was attempt. For example, when you initiate an in-place upgrade, your upgrade process or a separate script should create the marker. For example, so on later checks. So you can also add checks like looking for Windows.old if desired, but the marker file is the often simplest and most reliable. Okay, so this can be a good thing. So again, uh, this is script in place upgrade marker based. Mhm. So I think later we will have a script to have uh, or to make the upgrade process. So we have seen this before. Okay, so we need this upgrade. Let me see if we can uh, tell me what could. Okay, I can do this manual. What could the contain? Give sample data. So if I can add it manually to the file. So okay, okay, so we need to have. Okay, so we can put in place upgrade attempt, so and so. The simple format shows that an upgrade was attempted, so and so. Detailed marker. Okay, so this seems to be upgrade initialized manually via script. So okay, I think this can be a good approach. So now let's return back to our uh, real scenario. So now we are taking a decision to make an in-place upgrade or reset. Uh, so now I think here we have stopped here at one thing the last time. This is the system readiness for upgrade. So he is after deciding if to upgrade or to reset. If we try to upgrade, we have some prerequisites to do an upgrade. You need to check for minimum space, RAM, and what about something? Okay, and uh, we have the memory. So we have our system hardware exported to a text file, and then we are comparing, I think, to get the minimum requirement. Continue monitoring current repair. So we need to make a repair before the last repair before we do to an in-place upgrade. Should we review the readiness results and make a final decision? So uh, let me see the last one. We'll analyze our readiness decision. So here we can see we, after analyzing the requirements, if we can, I think actually if you make an in-place upgrade, so there's two situations. If we are upgrading from Windows 11 to Windows 11, then this is fair. We don't need to do anything. If you are upgrading from 10 to 11, then we need to take a serious look about the hardware requirement. So let's see here the decision tree concerning the readiness. So this is the output of this script. So let's see what he is doing or what he will do. Here is telling us current state, check the hardware requirement, system ready, yes, start upgrade, mount ISO, run setup, monitor process, system ready, no address issues, free disk space, create backups, and then return back to system ready. So this seems to be good, but uh, will it take uh, just a moment, will it take a backup before uh, uh, take a backup of create backup of the hardware, maybe hardware requirements, maybe not a real backup. This is backup of the uh, maybe state of the or the hardware, or he's taking a real backup. So okay, so let me stop at the readiness. So now we have stop at the readiness check result. So we have in this video we need to decide if we need to make an in-place upgrade or a reset, and this will be based upon a script that will check for certain criteria in the DISM logs and see if it really needs or we need an in-place upgrade or a reset. And if we decide to have an in-place upgrade, then we need to make sure our hardware can help us to have an in-place upgrade. If it's from Windows 10 to 11, you need to make sure you have TPM chip and a lot of things. If it's from the same operating system to the same operating system, then there is no need to do that. But anyway, this is a good step to verify if we have the hardware necessary. We need to have some free space, we need to have some memory requirement. So this is good. We will stop at this point, which is analyze our readiness check, and we will continue with Godwill in the upcoming video. Hope this video informative for you all, and thank you all for viewing. Thank you so much.